Video, we're going to take a look at basic probability. Basic probability is basically the number of desired outcomes divided by the number of total outcomes. That's it. Number one, suppose you toss a fair coin 4 times. How many different outcomes are there? When you think about probability, let's say we flip the coin 1 time. You have a choice of either getting heads or tails. After you get heads or tails, you then flip the coin a second time. If you got heads the first time, the second coin will either get heads or tails. If you flip the tails the first time, you can still get heads or tails in the second flip. Then you flip it again a third time. Again, we just repeat this process. You can get heads or tails for any of these possible outcomes. And then you flip it again one more time. We're doing this for 4 flips. So we get heads, tails, heads, tails, heads, tails, and so on. Okay, so now we have our complete tree diagram that lists all the possible outcomes. And if we need to find out the total number of outcomes, we can just count the number of things on the bottom, number of outcomes on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 16 total outcomes. Find the probability of obtaining no heads. No heads means we need only tails. And in that case, that would be this path that you see there. It looks like we only have one of those options though, because every other option is going to have a head in some other place, which we don't want. So therefore, we only have a 1 in 16 chance of getting no heads. Find the probability of obtaining at least one head. If we want at least one head, we can have 1 head, we can have 2 heads, we can have 3 heads, we can even have 4 heads. We have all the possibilities. Well, if you can have 1 head or 2 heads or 3 heads or 4 heads, then the idea there is basically that it's basically the rest of what we had not gotten previously, because you can just have anything with an H in it, right? And so if we know that there's a total of 16 out of 16 for the entire set, total possible outcomes, and if we knew that there was only a 1 in 16 chance of getting all tails, we can really just subtract the 2 from each other. We're saying that the total possibilities minus the probability of getting no heads. Okay, so total possibilities minus the probability of getting no heads leaves you with the probability of getting at least 1 head. And that probability would be 15 over 16. Find the probability of obtaining exactly 1 head. Okay, well, if we just want exactly 1 head, let's take a look at our possibilities. Whoops, I erased too much. Let's look at our possibilities. If you want exactly 1 head, you can think about the order in which you can go along the tree diagram, like heads, tails, 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 like this. This would be one possibility, right? Because you have heads come first, and then all you have are tails after that. The other possibility is maybe you flip the tails first, and then maybe the heads came second, right? So in that case, you would follow along the tree diagram in this fashion here. Tails, heads, tails, tails. Maybe that heads didn't come until the 3rd time around, right? And so if you think about all the possibilities, you see that there are a total of 4 possibilities out of, again, the 16 total possible outcomes. And so we see that you're going to get a 1 in 4 chance of getting exactly 1 head.